Stability is how the atmosphere will react when there is vertical motion of air. There are three types of stability: stable, neutral, and unstable. A stable atmosphere is one where, when the air is lifted, the air will return to its original position. In a neutral atmosphere, air that is moved will remain in its new location. And finally, an unstable atmosphere is one that when air is lifted, it will continue to rise freely up in the atmosphere. An unstable atmosphere is a key ingredient in the formation of large cumulonimbus clouds and thunderstorms. While poor visibility and low clouds can be a hazard to pilots, one of the most dangerous weather events is a thunderstorm. Thunderstorms need three main ingredients to form: sufficient moisture, an unstable atmosphere, and a lifting mechanism, like a front, to start it all. Thunderstorms contain several of the biggest hazards to aircraft, including such things as turbulence, wind shear, hail, tornadoes, lightning, and icing. Some of these hazards can occur outside thunderstorms as well. Turbulence. Air doesn't always flow smoothly and can develop into areas of flow that can be rough to fly through. Areas of severe turbulence can damage aircraft and injure occupants due to the abrupt movements. Wind shear is any change in wind direction or speed over a short distance. This can cause turbulence in the air and is especially dangerous near the ground. As an airplane is taking off or landing, the sudden change in wind direction or speed can suddenly affect the performance of the airplane. A sudden shift from a headwind to a tailwind can cause an abrupt and dangerous drop in airspeed and could cause the airplane to stall. If there is not enough altitude to recover, the airplane could impact the ground before stall recovery occurs. Icing is a very dangerous condition that can drastically affect the performance of the aircraft. Only approved and properly equipped aircraft can fly into areas of known icing conditions. Icing occurs when an airplane flies through an area of visible moisture, like rain or a cloud, where the temperature is below freezing. These water droplets are called supercooled droplets because they exist as liquid water at a temperature below freezing and will freeze upon impacting the surface of the airplane. Ice can form on any surface of the airplane, from the wings to the pitot tube and even the windshield and the propeller. The addition of ice to an aircraft will increase the overall weight of the airplane, and the ice on the leading edge of the wings will affect the airflow over the wing and create drag, both of which negatively affect the airplane. Aircraft use a variety of methods to combat in-flight icing. Smaller propeller-driven aircraft can use pneumatic inflatable boots on the front of the wing to pop off the ice once it forms. Propellers and windshields can be heated to remove and prevent ice from forming. Some airplanes will spray alcohol on the surfaces to keep the ice from sticking to the airplane. Larger aircraft that use jet engines will actually divert heat from the jet exhaust to heat the surfaces of the aircraft to melt and keep ice from forming. There are three different types of icing: rime ice, clear ice, and mixed ice. The size of water droplets determines the kind of ice that will form. Rime ice forms when small water droplets impact and freeze on the airplane. The smaller water droplets are usually found in a stratus or layer cloud with no vertical development. Rime ice is rough and whitish in color and will form protrusions on the front edge of the aircraft surfaces. In extreme cases, rime ice can form horns on the leading edge of the wing that interfere with the production of lift. Clear ice is formed when larger water droplets impact and freeze on the airplane. These larger water droplets are found in cumulus or cumulonimbus clouds where there is a lot of vertical development. When these large water droplets impact the airplane, they freeze and spread out over the surface. This gives clear ice a clear color and smooth finish. Clear ice is most commonly found on the leading edge of the wings where it will conform to the curve of the wing. This will interfere with the airflow over the wing, but its main hazard is the additional weight that is added to the airplane. The third kind of icing is called mixed icing. Areas with mixed icing are simply areas that have a combination of both rime and clear icing. Obstructions to visibility can pose a hazard to aircraft. Low visibility can make it difficult to see runways when landing, ground checkpoints while navigating on a cross-country, and even other traffic in flight. Haze, mist, fog, smoke, and dust can all get into the air and reduce the visibility. Any visibility less than 3 miles require aircraft to perform instrument approaches to land at the airports. In extreme cases, the visibility can drop to zero, making it nearly impossible to land in most aircraft. There are many different weather hazards in aviation to be aware of, but even simple things like the wind direction can play a big role in flight planning. In fact, federal regulations require that, quote, each pilot in command shall, before beginning a flight, become familiar with all available information concerning that flight, including weather reports and forecasts, end quote.